Hubble's greatest discoveries, unveiling the mysteries. Universe. During its 25-year-long mission, the Hubble Space Telescope has changed our view of the universe significantly. Some of the most groundbreaking discoveries made in astronomy in the 20th century were made by Hubble, which allows astronomers to better understand the world we live in and investigate its mysteries even further. The Hubble Deep Fields. How Hubble has observed the furthest away galaxies and the most ancient starlight ever seen by humankind. One of the main scientific justifications for building Hubble was to measure the size and age of the universe and test theories about its origin. Images of faint galaxies give fossil clues as to how the universe looked in the remote past and how it may have evolved with time. The deep fields gave astronomers the first really clear look back to the time when galaxies were forming. The first deep fields, Hubble Deep Field North and South, gave astronomers a peephole to the ancient universe for the first time, and caused a real revolution in modern astronomy. Subsequent deep imagery from Hubble, including the Hubble Ultra Deep Field, has revealed the most distant galaxies ever observed. Because of the time it has taken their light to reach us, we see some of these galaxies as they were just 500 million years after the Big Bang. Deep field observations are long-lasting observations of a particular region of the sky intended to reveal faint objects by collecting the light from them for an appropriately long time. The deeper the observation is, i.e. longer exposure time, the fainter are the objects that become visible on the images. Astronomical objects can either look faint because their natural brightness is low, or because of their distance. In the case of the Hubble Deep and Ultra Deep Fields, it is the extreme distances involved which make them faint, and hence make observations challenging. Using the different Hubble Deep Fields, astronomers were able to study young galaxies in the early universe and the most distant primeval galaxies. The different deep fields are also a good gathering grounds to find the most distant objects ever observed. Within 2012 and 2014, Hubble created 2 new deep fields. The Hubble Extreme Deep Field is so far the deepest image ever taken of the sky so far and combines the light of 1 million seconds of observation. The last Hubble Ultra Deep Field released in 2014 was observed in ultraviolet. This image allowed astronomers to study star formation in a region 5 to 10 light-years away from us. Age and size of the universe. How Hubble has calculated the age of the cosmos and discovered the universe is expanding at an ever faster rate. The top-ranked scientific justification for building Hubble was to determine the size and age of the universe through observations of Cepheid variables. The periodic brightness variations of these stars depends on physical properties of the stars such as their mass and true brightness. This means that astronomers, just by looking at the variability of their light, can find out about the Cepheids' physical nature, which then can be used to determine their distance. Astronomers have used Hubble to observe Cepheids with extraordinary results. The Cepheids have then been used as stepping stones to make distance measurements for supernovae, which have, in turn, given a measure for the scale of the universe. Today we know the age of the universe to a much higher precision than before Hubble, around 13.7 billion years. The expansion of the universe. Another purposes of Hubble was to determine the rate of expansion of the universe, known as the Hubble constant. After 8 years of Cepheid observations, this work was concluded by finding that the expansion increases with 70 kilometers per second for every 3.26 million light-years you look further out into space. For many years, cosmologists have discussed whether the expansion of the universe would stop in some distant future or continue ever more slowly. The observations of distant supernovae made by Hubble indicate that the expansion is nowhere near slowing down. In fact, due to some mysterious property of space itself, called dark energy, the expansion is accelerating. This surprising conclusion came from combined measurements of remote supernovae with most of the world's top-class telescopes, including Hubble. The discovery of the accelerating expansion of the universe led to 3 astronomers, Saul Perlmutter, Adam Rees, and Brian Schmidt, being awarded the 2011 Nobel Prize in Physics. The lives of stars. How Hubble has revolutionized our understanding of the birth and death of stars. Most of the light and radiation we can observe in the universe originates in stars, individual stars, clusters of stars, nebulae lit by stars, and galaxies composed of billions of stars. Like human beings, stars are born, mature, and eventually die. Hubble has gone beyond what can be achieved by other observatories by linking together studies of the births, lives, and deaths of individual stars with theories of stellar evolution. In particular, Hubble's ability to probe stars and other galaxies enables scientists to investigate the influence of different environments on the lives of stars. This is crucial in order to be able to complement our understanding of the Milky Way galaxy with that of other galaxies. Uncovering the galaxy's stellar nurseries. Hubble's work allowed it to link star formation with stellar evolution. Its infrared instruments are capable of looking through the dust clouds surrounding newly born stars. Some of the most surprising discoveries so far have come about by peering through the clouds of dust surrounding the center of our Milky Way. Astronomers found that this center, which was thought to be a calm and almost dead region, is in fact populated with massive infant stars gathered into clusters. Stellar skeletons. The last phases of solar-like stars have been investigated through observations of planetary nebulae and protoplanetary nebulae. These are colorful shells of gas expelled into space by dying stars. The varying shapes and colors of these intricate structures with different colors tracing different, often newly created chemical elements, have shown that the final stages of the lives of stars are more complex than once thought, and there also seems to exist a bizarre alignment of planetary nebula. Gamma-ray bursts. Gamma-ray bursts emit very intense gamma-ray radiation for short periods and are observed a few times per day by special gamma-ray detectors on observatories in space. Today, partly due to Hubble, we know that these bursts originate in other galaxies, often at very large distances. Their origin has eluded scientists for a long time, but, after Hubble observations of the atypical supernova SN 1998 BW and the gamma-ray burst GRB 980425, a physical connection of these became probable. An unusual burst of radiation detected in early 2011 may tell a different story. Rather than a star ending its life in a supernova, this burst may be evidence of a star being ripped apart as it falls into a supermassive black hole. If confirmed by further observations, this would be the first time this phenomenon has ever been spotted. The solar neighborhood. What Hubble has taught us about planets, asteroids, and comets in our own solar system. Hubble's high-resolution images of the planets and moons in our solar system can only be surpassed by pictures taken from spacecraft that actually visit them. Hubble even has one advantage over these probes. It can look at these objects periodically and so observe them over much longer periods than any passing probe could. Regular monitoring of planetary surfaces is vital in the study of planetary atmospheres and geology, where evolving weather patterns such as dust storms can reveal much about the underlying processes. In comparison with probes that have to travel vast distances and require years of planning to visit the planets, Hubble is also able to react quickly to sudden dramatic events occurring in the solar system. This allowed it to witness the stunning plunge of comet Shoemaker-Levy 9 into Jupiter's atmosphere during the period the 16th to the 22nd of July 1994. Hubble followed the comet fragments on their last journey and delivered incredible high-resolution images of the impact scars. The consequences of the impact could be seen for several days afterwards, and by studying the Hubble data, astronomers were able to gain fundamental information about the composition and density of the giant planet's atmosphere. Since the impact of Shoemaker-Levy 9, Hubble has continued to study impacts and events on Jupiter, improving our understanding of the solar system's largest planet. Like, comment, share and subscribe to my channel.